For this lesson, we're going to be solving quadratics by factoring. So let's take a look at this first example. We need to solve for all values of x by factoring. So I'm going to write down what I started with. X squared minus 13x plus 4 equals negative 6x minus 2. Your first goal is to get this entire thing into standard form. So if you remember from the last lesson, our standard form, we want to have descending order where our x squared term piece is first, then our x term, then our constant, our piece that's just a number, but we want it set equal to 0. So I need to take both of these terms and get them over to the left-hand side. So I'm going to start by doing this in one step. So if this is a negative 6x, to get it to the side, I need to add 6x. I'm going to make sure I am adding it underneath the x terms, that I'm combining like terms. And if this is a negative 2, I need to add 2 to get it to the other side, making sure to place it underneath the other constant of 4. Now looking at what I have left, I'm going to bring down my x squared piece that I haven't touched. I know that negative 13x plus 6x leaves me with negative 7x. Positive 4 and adding 2 more leaves me with plus 6. Set that equal to negative 6x plus 6x are a 0 pair, they cancel out. Negative 2 plus 2 are a 0 pair, they also cancel out. Once we have it in standard form, your goal is to factor it. So whenever we're factoring things, we want to first look to see if there's a GCF that we can divide every single term by. I have this x squared term is the same as 1x squared right here. I have a negative 7x and a positive 6. Every single term doesn't have an x. Every single term doesn't have a coefficient or a number that I can divide it by. So I'm going to skip GCF. And I can see that since this x squared term piece doesn't have a number in front of it and a equals 1, I'm going to start by doing my quick trick of factoring a trinomial when a equals 1. So let's go over that quick trick. This quick trick tells you that you want to solve a diamond problem where you are multiplying to this top number, which is always the last term in your trinomial. And so you're multiplying to 6, and you're trying to add to the middle number. So you're trying to add to negative 7. If you can't automatically do these diamond problems in your head, then it's important that you start by listing out the factors of the top number. So I'm going to start by listing everything that multiplies to 6. So I have 1 times 6, 2 times 3, 3 times 2 is the same thing, 4 doesn't work, 5 doesn't work, and then we're back to 6, which we've already listed. Now looking at my options, I'm going to see which of these options adds up to a negative 7. And when I first look at this, I see that all of my options across are adding up to positive numbers. When this happens, when you want to multiply to a positive but add to a negative, you need to make this double negatives. Multiplying negative 1 times negative 6 does multiply to positive 6. And when I add negative 1 plus a negative 6, I end up getting that negative 7. So I found the pieces that work. So I'm going to place negative 1, negative 6 right here to finish my diamond x problem off. Once you find these two pieces, you're able to factor it. So you're going to start by doing parentheses with an x at the front of the parentheses both times. Still have it set equal to 0. And whatever numbers you get to finish off your diamond x problem are the two numbers that go inside the parentheses. And the order of these doesn't matter. You could have negative 1 right here in the first parentheses, or you could have placed it right there. As long as one of them has a negative 1, one of them has a negative 6. And then we have one final step because we factored it so far, but we haven't solved for all values of x by factoring. So I need to use my zero product property. That tells me when two things are being multiplied and they equal 0 when we multiply them, then either this first piece has to equal 0 or this second piece has to equal 0. So I'm going to set both of them equal to 0. First parenthesis equal to 0, second parenthesis equal to 0. And then you actually have to solve both of them for x. So you want to get the x by itself by adding 1 to both sides, our first answer, x equals 1. You want to add 6 to both sides. Our second answer, x equals 6. And we've solved this one by factoring. Let's write down this second example. We start with x squared minus 13x equals negative 5x. Our goal again is to start by getting into standard form. So I want it to be set equal to 0, so I need to add 5x to both sides. My 0 pair cancels out. I'm left with x squared. Negative 13x plus 5x squared gives me negative 8x. That's set equal to 0. And again, as soon as we have it in standard form, we want to try to do GCF. And when I look at these two pieces on the left, both of these two pieces are divisible by an x. So I'm going to divide both pieces by x. Keep it on the outside of your parentheses. Inside of the parentheses is what we have left when we divide both the pieces. So x squared divided by x gives me x. Negative 8x divided by x gives me negative 8. And now I want to be able to set these two things equal to 0 because multiplying them equals 0. Either this piece will have to equal 0 or this piece will have to equal 0. This one's already solved for. This one will add 8 to both sides and we'll get x equals 8. And then our last example, the third kind of problem that you can see during this lesson, when you start out with x squared minus 2x minus 12 equals negative 2x plus 4. Again, you want to start by getting it into standard form. So we're going to add 2x to both sides. And we are going to subtract 4 from both sides. I'm left with my x squared to be brought down. Negative 2x plus 2x cancel out to give me no more x's. They're a 0 pair. Negative 12 minus 4 leaves me with negative 16. Negative 2, positive 2 cancels out. Positive 4, negative 4 cancels out. Again, once you have it in standard form, you automatically want to look for if you have a GCF that you can divide each of the pieces by. This has an x squared but no coefficient. This is the number negative 16 but no x's. There's nothing that you can divide them both by. So what you're going to look for is if you can do your difference of squares rule. Difference of squares has a couple things that you need to make sure in order to use it. First, this first piece has to be a perfect square. X squared is a perfect square. X times x equals x squared. Secondly, this last piece has to be a perfect square. 16 is a perfect square because 4 times 4 equals 16. And then the last thing that you need to make sure is that there is a negative sign in the middle right here because it's called difference of squares. It needs to be difference, subtraction, not an addition. So we're able to start our difference of squares rule where we take the square root of the first and the last piece. We set up our parentheses equal to 0. The square root of x squared, this first term right here, is just x, so x goes at the front of both my parentheses. The square root of 16 is 4, so 4 goes at the back of my parentheses. Difference of squares rule tells you that 1 is going to get a plus, 1 is going to get a minus. Now we have the product, two things being multiplied together to equal 0. We'll do our 0 product property, x plus 4 equals 0, x minus 4 equals 0. Solve for x, subtract 4 from both sides, we get x equals negative 4. Solve for x, add 4 to both sides, we'll get x equals positive 4.